Today's talk is on perfect secrecy. We have several cryptosystems, but the main question we have is to know whether a particular cryptosystem is perfectly secure or not. Basically, what we do in the cryptosystem, we have an encryption algorithm. Similarly, we can consider the decryption. Okay, here we take encryption. Given a plain text, based on a particular key K, the encryption algorithm will encrypt the plain text and produces the ciphertext that is called. Here, the plain text is converted into some other format in order to make the people do not understand what the actual content in it. However, there are several cryptanalysis mechanisms are there, like differential cryptanalysis, linear cryptanalysis. So like that, they can make use of various cryptanalysis to get the plain text. So if the cryptosystem is not good enough, then obviously those cryptanalysis will tell them that what the plain text is. So we should know that whether our cryptosystem is perfectly secure or not. For that, we have to consider the probability. Here there are three components: plain text, key and the ciphertext. The plain text, we have a set of plain text, collection of plain text. In that, we select one particular plain text, and similarly, we have a set of keys. We choose any one particular key, then using that key, and the plain text will be converted into the ciphertext. So when we have a collection of plain text, now the question is, what is the probability of choosing a particular plain text? So we define a probability distribution. Why we say it's a probability distribution? The total probability is what? That the total probability will be distributed among all the members of the set. Therefore, here we have a collection of plain text. If you select a particular plain text, similarly when you consider the probability distribution, we will associate that with the random variable. So in this case, if you say capital X is a random variable corresponding to the probability distribution which we stated for the plain text, then for selecting a particular plain text small x, the probability is P of x is equal to x. But we can simply say that is a P of x, but we have to assume that there is a variable involved, but for the simplicity we can take that as a P of x. So we define a probability of a plain text. Similarly, we have a collection of keys that is called the key space. So from the key space, if you select a particular key, the probability is P of K. So we have defined probability for the x and probability for k. Now the third thing we have here is the ciphertext. But how we get the ciphertext? We need a plain text and a key in order to get the ciphertext. Therefore, the probability of the ciphertext is purely based on the probability of plain text and the key. What I want to say here is the probability of the plain text and the probability of the key, that together will induce the probability of the ciphertext. Therefore, if you say P of y is the probability of the ciphertext, then this is based on two things, right? One is the probability of k, the key we have to select, and the corresponding plain text. how we get the corresponding plain text? That is, for this particular key, if you take arbitrary plain text, that cannot lead to this y. Therefore, we have to select the corresponding plain text. How we define that? So that is P of T K of y. So D is the decretion algorithm. With the same key, if you decrypt the ciphertext y, we get the corresponding plain text. But we multiply this. We need this probability of K and the probability of this plain text. Moreover, these two are independent. The reason is the choice of key is not based on, it is not being selected based on the knowledge of the plain text. It is not like that. So first we select the key, then whatever the plain text comes, we will encrypt and get the ciphertext. So these two are independent. Okay. Now what happens is this is only one choice. Like that, when you select another key, then the corresponding plain text again gives the y. So there are several choices. So either this or that, something like that. Therefore we can take the sigma. But what we are very clear, that is the TK. So this is the probability of the ciphertext. Now what we want is, when you have a plain text, you have to get the ciphertext, that is probability of y given x. Okay, so this is the knowledge of x is not given, probability of y. So all the choices we have considered, right? So in this case, the probability of y given the plain text. Now what we want? We want a key. Therefore, to get this y, the choice is depending on the key. Therefore, this probability is equal to probability of k. But once again, there are several choices that is possible. So we can put a sigma, and the sigma varying over k, but okay, this x is equal to dk of what? The corresponding corresponding x, which lead to y. For that, whatever the key we used, that probability we are considering. Therefore, this is probability of y given x. Now, the attacker, he is having the ciphertext. He has to get the plain text. Then we see the probability of getting the plain text given a ciphertext y. So this is the conditional probability. So by knowing this y, what's the probability of getting this x? That is probability of x given y. So this is equal to, due to Bayes theorem, this is probability of x, then probability of y given x divided by probability of y. But we know probability of y, we know probability of x, also we know probability of y given x. Therefore we can get this. Now one way we use these probabilities. There are several probability measures we have considered. Now when you say the probability of x given y, that is equal to probability of x. What does it mean? That is probability of getting this x with the knowledge of y is equal to probability of getting this x without the knowledge of y. So whether you know the ciphertext or not, getting the plain text is the difficulty is same. Therefore, by knowing the ciphertext, the attacker is not going to get the plain text, right? It is similar as that of without knowing the ciphertext. So if any crypto system that satisfies this property, then we will say that crypto system is perfectly secure.